Have you ever looked up at the sky and marveled at a plane gliding effortlessly through the clouds? It's a fascinating sight, and many people wondered just how these massive machines manage to stay airborne. Today, on Everything Explained, we're going to break down the science of how planes fly, making sense of the different forces at play and the technology that keeps us soaring high. To start, let's talk about the four fundamental forces that work together to help an airplane fly: lift, weight, thrust, and drag. Think of these forces as characters in a story, each playing a crucial role in the flight of an airplane. First up is lift. Lift is the upward force that counteracts the weight of the plane. It's generated primarily by the wings. When a plane moves forward, air travels over and under its wings. The shape of the wings is designed to create a difference in air pressure. The top surface of the wing is curved, while the bottom surface is flatter. When the plane moves, air moves faster over the curved top surface, creating lower pressure above the wing compared to the higher pressure underneath. This difference in pressure creates lift, helping the plane rise into the air. Now, let's relate this to something more familiar. Imagine holding your hand out of the window of a moving car. If you tilt your hand slightly, you'll feel it being pushed upward. That's similar to how lift works for an airplane. The faster the plane goes, the more air flows over the wings, and the more lift is generated. Next, we have weight, which is the force of gravity pulling the plane down toward the earth. This force is determined by the mass of the airplane and everything it carries, including passengers and cargo. For a plane to take off, the lift must be greater than the weight. Once the lift overcomes the weight, the plane can ascend into the sky. The third force is thrust. This is the forward force that propels the airplane through the air, and it's generated by the engines. Imagine riding a bike. When you pedal, you're providing thrust that moves you forward. Similarly, airplane engines, whether they're jet engines or propellers, push the plane forward at high speeds. This forward motion is crucial because, as we discussed earlier, lift only occurs when there is enough airflow over the wings. Lastly, we have drag. Drag is the resistance that acts opposite to the direction of thrust. Think of drag as the air pushing back against the plane. It's similar to trying to walk through water. Water pushes against you, making it harder to move. In aviation, the shape and design of the airplane play a massive role in minimizing drag. Engineers focus on making planes as aerodynamic as possible, which helps them cut through the air more efficiently. Now, let's put these forces together. When a plane is ready for takeoff, the engines generate thrust, pushing it down the runway. As it picks up speed, lift begins to build. Once the lift exceeds the weight of the plane, it takes off. During flight, pilots must constantly balance these forces. If they want to climb higher, they need to increase thrust or adjust the wings to generate more lift. If they want to descend, they reduce thrust, allowing drag and weight to bring the plane down gradually. The beauty of flight doesn't just stop at these four forces. Airplanes are equipped with various control surfaces that help pilots maneuver the aircraft. For instance, ailerons, located on the outer wings, help the plane roll left or right, while elevators at the tail control the up and down motion. Rudders, also at the tail, help steer the plane left or right. These surfaces work in tandem with the four forces, allowing pilots to navigate through the skies safely. Let's take a moment to consider the technology involved in flying. Modern airplanes are marvels of engineering, equipped with advanced navigation systems, autopilots, and safety features that ensure a smooth journey. For example, many commercial jets use fly-by-wire technology, where electronic signals rather than mechanical linkages control the flight surfaces. This makes flying more precise and responsive. Now, you might be wondering how weather affects all of this. Wind, turbulence, and storms can influence lift and drag. Pilots are trained to handle varying conditions and use weather reports to plan their routes. Sometimes, they may need to change altitude or direction to find smoother air, demonstrating how agile and adaptable flying can be. As we wrap up our exploration of how planes fly, it's clear that the combination of lift, weight, thrust, and drag, alongside advanced technology, allows us to travel across the globe in ways that were once unimaginable. The next time you see a plane soaring overhead, you'll have a deeper understanding of the incredible forces at work. Flying might seem like magic, but it's really a beautiful blend of physics, engineering, and a little bit of human ingenuity. So, whether you're a frequent flyer or just someone who enjoys watching planes, remember that there's a lot more to that flight than meets the eye. Until next time, keep looking up and wondering about the wonders of our world.